we got this situation, intersection of a line and a parabola. Okay, now look at this. In this kind of situation, what we will get? We will get a equation of straight line y equals mx plus c, and also you can convert any equation of straight line into this form. It's a general form, and they are talking about parabola, so I'll be taking standard parabola. Y square equals to 4ax. Now try to connect with this explanation. Like, while dealing with this kind of situations, now you will have a curve and a straight line. This curve can be anything. It can be circle, parabola, ellipse, hyperbola. Okay, now look at the situations we will be facing. So suppose that this is the curve, okay, and suppose that this is the straight line. So you can say that, sir, we will have this situation. The straight line and the curve will meet at 2 points, or the straight line and the curve will touch at 1 point, and straight line and the curve will have no cut, no touch situation. Correct? So how we will handle this kind of situations? Now try to understand this part. Try to recall that concept that we have studied in pair of straight lines or straight line in class 10th. Like we used to have two straight lines. We used to apply substitution, and then we used to get intersection point. So look at this. Suppose you have applied substitution in this case as well. So if you will fall in this case, you will get 2 points. Okay, if you will solve this case, you will have 1 point, and if you'll go with this case, you will have no intersection point. So how we will connect? Now try to observe after substitution what happens. Suppose that you have substituted value of y in this equation. So hopefully you will get quadratic in x or quadratic in y. So you guys are getting quadratic. Now quadratic has two roots. Now look at this. Look at this case. Here you guys are getting two distinct intersection point. So can I say that in this case d will be greater than 0? Then only we used to have real and unequal roots, na? So real and unequal point of intersection. Now look at this case. Here we guys are getting one intersection point, but it is 2-degree curve. So can I say that both intersection point are same? It is only possible if d is equal to 0. Now look at this case. In this case we have no cut, no touch situation. So can I say that d is less than 0? Okay. Now look at this. I'll apply the same concept, and I'm interested in finding condition for tangency. Okay. Now look at this. I'll substitute. So can I place value of y in this part? So mx plus c whole square equals 4ax. Now open this bracket. M square x square plus c square plus 2mcx. Can I ask 4ax to come this side? So 4ax equals to 0. Now as I have told you that we will have quadratic in x or y. Right now we guys are getting quadratic in x. So can I write m square x square plus 2mc minus 4ax plus c square. So we got our quadratic in x. Okay, and we guys are interested in condition for tangency. So can I put d equals to 0? है ना? So I will write b square. B is this thing. So b square, I'll take 2 common. So b square, 2 square will become 4. So b square sorry, it will become 2. B square minus 4AC will be equal to 0. Now, can I divide both sides by 4? Done, done. Now, let's open the bracket. So, m square c square plus 4a square minus 2amc minus m square c square. Now, you can simplify things. So, m square c square gone. Okay. This thing will become 4 because it is 2ab now. So 2 times this will become 4a and mc. So 4amc. Okay. Now can I send this thing that side? So we will have 4a square is equal to 4amc. So 4 and 4 gone. A gone. So we got a equals to mc. This is the condition for tangency. Okay, this means this point should be the product of these two things, then the straight line y equals to mx plus c will behave as tangent for this curve. I hope the idea is clear.